Hello, so let's start. Graph the function f of x is log of x minus 1 base 2, base 2, yes. So guys, what we know here, since we already have the graphs, we have to select the correct one. And what is the domain here? Since here x minus 1, remember, that should be positive, right? So x minus 1 should be positive. It means x is greater than 1. Look, x is greater than 1 is the domain. So A cannot be the answer. B cannot be the answer. All right? So D cannot be the answer. There is only one option. I just checked the domain. Or if I'm not sure about that, what else I can do? I just find the number table, yes? All right, if x is equal to 2, if x is equal to 2, what is the log of 1 base 2? Log of 1 for any base is 0. x2, y0. The 2, 0 must be the point, and that point is here. Okay. Or anyway, if x is 3, then we will have 2 here. Log of 2 base 2, it is 1. At 3, it is 1. The answer is C. Please let me know if you have any questions. Number 2. Look at the graph. Which of the following statements is true? The true one is asked. Okay. I'll get closer maybe. Okay. So the domain of f of x is all real numbers. No, unfortunately, it's not true. Domain x greater than 0. You see, we have no graph on the left side of the y-axis. So domain x greater than 0. The range of f of x is y greater than 0. Unfortunately, it's not correct. The range, all real numbers. You see, y, for positive values of y, we have a part of the graph. For the negative values of the graph, we have a part of the graph. It means here, range, all real numbers. The x-intercept is 1, 0. Is it 1, 0? So it's not understandable from the graph. So let's see if satisfy these values, the function. Where x is 1, see, this is natural logarithm, ln. We are looking for ln 1. What is ln 1, guys? ln 1, so the base is e here. Let's say y, e to the power of y is equal to 1. Which power of e is 1? That is 0. Okay, it is the correct one. Let's check the other one. F of x is an asymptote at y is equal to 0. Unfortunately, this is not correct. It has an asymptote at x is equal to 0. Okay, the vertical line. Y is equal to 0 is the horizontal line. Okay, so the answer is H. I hope it's clear. The next question. Number 3. Which of the following statements is not true about the function f of x? Okay, not true. Pay attention to this. The x-intercept is 5, 0. How do you find the x-intercept? In case y is equal to 0. I just plug the y value, so the function value is 0. Let me check. I don't know. If 0 equals log of 5 minus 4. I don't know about this. So 5 minus 4 is 1. Is 0 equal to log base 10 of 1? Well, 10 to the power of 0 is 1. Guys, all the time when we have logarithm, please don't forget this, all right? So when we have log of a base b is c, we don't forget how we write this in exponential form. B to the power of c equals 8. We always use this conversion, okay? Between logarithmic and exponential functions, we never forget this. And here, by the way, we use this one. From this, 10 to the power of 0 is 1. Yes, it is true. So this one is true. The second one, there is no y-intercept. There is no y-intercept. Well, how can I know that? Y-intercept in case x is equal to 0. Okay. I can find the y-intercept in case x is equal to 0. Let me plug there 0. So y equals log of 0 minus 4 base 10. Oh, there's a problem here. You see, this must be positive. Remember, guys, also here we had the domain is always, so log of function, that function always must be positive. If I edit here, so yes, so A must be positive and B must be positive. Also, B must be different than 1. Please have these guys in the index card. All right. So, yes, it's correct. There is no y-intercept because there is no y value for where x equals 0. The domain is x greater than 0. All right. How do you find the domain? Domain is, it's x minus 4. Domain that should be greater than 0. Okay, this function should be greater than 0, the domain. And from here, we have x greater than 4. It says domain is x greater than 0. It looks like this is not true. Let's check the other one. The range is all real numbers. Range is all real numbers. Logarithmic function, generally, guys, general shape of logarithmic function is this one. Yes, range all real numbers. So here, the wrong one is C. I hope it is clear. Number 4. Please let me know in chat if you have any questions. Consider the function g of x is log of x minus 4 base 10 and describe the effect of the transformation on the parent function f of x. So what happened here? You see the difference is here. X became x minus 4 and it is in parentheses. So the graph is shifted 4 units. Right. This is the answer. Very good. When we have minus, we shift it right. Okay. When we have plus, we shift it left. Don't forget this. Number 5. What is the domain of the function? Another domain question. Very good. So this is our function in logarithmic function. X plus 5 must be greater than 0. Attention, guys. Log of a must be greater than 0. It is true for logarithmic functions or ln functions. This function must be greater than 0. And we have x greater than -5. This is the domain. Clear? Number 6. Oh, another graph. So let me make it bigger here. Yep. Graph the function 1/4 times log of x base 2 and describe the effect of the transformation on the parent function. So what we have here, the difference is 1/4. 1/4, 1/4. And guys, logically, since it was the parent function, here what happens? All the values of the parent function get smaller 4 times. We divide all the values 4 times, right? So as you see, it is not like that because it gets smaller. And it's not like that because we have, again, positive and negative y values. So which one it is now? Well, we basically just pick a value and try. If, guys, x is 2, if x is 2, so I know the log value here is 1 and 1/4. So x is 2, y is 1/4. Here for x is 2, that is more than 1. Guys, this is 1. But here x is 2, 1 here, it's 1/4. The answer is F. The graph is, what is it, shrunken, compressed, I think they had to say. Okay. Is it clear? Next question. Oh, another graph we have. Cool. And graph the function f of x, determine the coordinates of its intercepts. What we know, guys, this is a logarithmic function, general logarithmic function. And what is the domain here? Domain is, so let me write the domain here. Domain. So the function x plus 8 in logarithmic function must be greater than 0. So x must be greater than -8. Hey, look at here. It's less than. So a cannot be the answer. Look at here. Less than. It cannot be the answer. Okay. A part of the graph is, I don't know what happened here. I will check it out. I think they are like this. So they look very similar. So guys, let's find the intercepts, okay? Let's find the intercepts. How do you find the x-intercept? Where y is equal to 0, remember. So the x-intercept, to find the x-intercept, what I do? Y is equal to 0. So this is my function. 0 equals log of x plus 8 with base 2. I write this logarithmic function as exponential function. So 2 to the power of 0 equals x plus 8. 1 is equal to x plus 8. And from here, x is -7. So the x-intercept is -7, 0. All right. Well, in both, x-intercept is -7. You see, guys? It's -7, 0, and here it's -7, 0. Okay, what about the y-intercept? X-intercept, graph is okay, but look at here, we got it. Look, it's written x-intercept 0, 3. No, my dear, x-intercept is -7, 0. So here it is. All right, let's check the y-intercept. How do you find the y-intercept? To find the y-intercept, what we do? We take the x value as 0, right? Where x is equal to 0. So in my function, I plug the 0 value for x. It's log of 0 plus 8 base 2. So that is logarithm of 8 with base 2. How can I write 8? As 2 cubed. So that is logarithm of 2 cubed base 2. You know, guys, what we do with the exponents. So it's equal to 3 log of 2 base 2, and that is 1. 3 times 1 is 3. and the y-intercept is x0, y3. And yes, it's correct. The answer is this one. It's a nice question. The graphs same, but here they just changed x-intercept and y-intercept. We have to be aware. Don't pay attention to the graph only, but also check the written text below the graphs. Next question, expand the logarithmic expression. The logarithmic expression is, all right, here I see a division. So I write it as subtraction, you are right. Minus log of 9 base 2. Okay. What can I write here? 64. Can I write it as a power of 2? Yes, it is the 6th power of 2. So I have base 2. What about 9? Well, 9 I cannot write with base 2, but I can write it as 3 squared. Guys, we know what to do with the exponents here. And that is 6 log 2 base 2 minus 2 logarithm of 3 base 2. And the final answer is this log of 2 base 2 is 1. So that is 6 minus 2 logarithm of 3 base 2. Okay, this is the expanded version of the given question. All right, I hope it's clear. Next question. Wow. Let's solve them all. Number 9. Solve the exponential equation. All right. And we have just studied this one. If we have this one, guys, can I write both sides with the same base? I think so, right? Because the 1 over 3, I can write as negative 1 power of 3. And 27 is which power of 3? Yes, it is 3 cubed and the power 2x minus 5. And so I have 3 to the power of minus 1 is equal to power of power, it's their multiplication, 6x minus 15. What do I know? If I have two exponential function in one equation, and their bases are equal, it means, and the exponents must be equal to each other. So I just ignore after this step, I ignore the bases, I ignore the equal bases, and I write the exponents equal to each other. Negative 1 equals 6x minus 15. And from here, negative 1 plus 15 is equal to 6x. That is 14 is equal to 6x. Right. And to find x, I divide both sides by 6. X is equal to 6 over 14. Actually, if I simplify, x is 3 over 7. This is the answer of number 9. Yeah. Okay. I hope it's clear. Everything is visible. Number 10. Solve for x. Okay. Maybe some of the questions we didn't study yet since the test on Thursday, but I will solve all of them here. And since we know solving exponential equations, some logarithmic equations we don't know, but I hope you will understand more after the class. So check your solution also, it says. We have logarithm, the sum of two logarithms. Guy, we have to write this as logarithm of 2x times 8. Yes? It's equal to 3. what we do, if we have sum of two logarithms, we can condense them and we can write as one logarithm. So we have logarithm of 18x equals 3. What is the base here? Base is 10, right, guys? So I write this as exponential. Remember, when we were solving exponential equations, we in case of necessity, we can write it as exponential functions, logarithmic functions. And here, logarithmic equations we write as exponential. So 10 to the power of 3 is equal to 16x. Here it is. 10 to the power of 3 is 16x. So 1000 is 16x. If we divide both sides by 16, x is 1000 divided by 16. If I simplify this, so 508, I simplify, so 508, so 250 to 4, and 125 to 2. Okay, so x is 125 over 2. It says check your solution. How we are going to do, guys? Well, I substitute this value here. And okay, let me try it here. 2 times x, so 2 times 125 over 2, that will be log 125, okay? And plus log 8 is really equals 3. So we can make this checking by calculator, or let's try to do it, guys. 125 is what? Which power of 5? Yeah, we can write it as a power of 5. Well, not necessarily. Since it is the addition, I can write log of 125 times 8 is equal to 3. That is log of 1000, because 8 times 125 is 1000, is 3. And if I write this as exponential, I have 10 cubed is equal to 10. Yes, it's correct. So this is the answer. Is it clear? Is it clear? Good. Number 11. How many questions do we have? 20. Good. Write the expression as a single natural logarithm. Okay. Well, in case we have pluses and minuses, we go from left to right. We have what, guys? So first, I work with the coefficients. ln 2 to the power of 5 plus ln 5 to the power of 5 minus ln 10 to the power of 2. This is the first step. And now, what about this? Their addition of two natural logarithm, I can write it as ln 2 to the power of 5 times 5 to the power of 5 and minus ln 10 squared. Okay. And so before starting to work with subtraction, here in the parentheses, what is it, guys? It is ln 10 to the power of 5. So 2 to the power of 5 times 5 to the power of 5, it's 10 to the power of 5. So it is minus ln 10 squared equals. And now we have a division. We have ln of x cubed, because 5 minus 2 is 3. And that 3 I can write here as 3. So 3 ln 10 is the final answer. Is it clear? Number 12. Write the expression as a single logarithm. Okay, similar. Well, here, that 2 first I work with. So log base 10 of 81 minus log base 10 of 3 squared. Yes, guys? And that is equal to log base 10 of 81 minus log of 9 base 10. We have subtraction. Subtraction we write as division of the index. So we have 81 over 9 base 10. That is log of 9 base 10. Okay. Well, this is the single logarithm. We can write also, this may be multiple choice question. So answer may be like this, or it may be 2 log 3 base 10. Since 9 is 3 squared and 2 I can write as coefficient. Both of them are okay, guys. Number 13. Number 13, write the expression as a single logarithm. All right, good. So we have any power? Yes, let's work with this power first. 196 base 2 minus, so if 2 becomes the square of 7, I have here 49 base 2 plus log of 10 base 4. Very good. So now what I'm doing, attention. Here it's a bit tricky. So from left to right. So the first 2, it's this one, log of 196 over 49 base 2. And then plus log of 10 base 4. Right, guys? And then, so it's plus 10. Attention, I multiply this by 10. Can I make any simplification here? 196 and 49. It is 4, right, guys? Yes, it is 4. Good. So I have log of 4 base 2. Oh, wait a minute. There is a problem here because it's log of, not problem, but I cannot multiply these numbers because the bases are different. You see? Pay attention to the bases, 2 and 4. Then, is there any way to make the bases equal? Yes, okay. We have to be careful. That 4 can be written as 2 squared. Right, guys? So 4 is 2 squared. And that squared, that power of 2 can be written in front of the logarithm. How do we do it? Remember, so I write the first logarithm plus, so here, pay attention, it's log of 10 2, so that square comes here in denominator. So here I have 1. All right. Okay. And then, look, but I shouldn't have any number here. Then I write this number as the power of 10. Wow. It's nice. Okay. So I have the first logarithm same plus logarithm of two logarithms, bases are same. I can write it as log of 4 times square root of 10 base 2. Okay? As a single logarithm. This is the single logarithm. Is it clear? Number 14. Okay, number 14, find all solutions of the following equation. Yeah, this one we didn't study yet in the class. And how do we solve this, guys? We have to remember, in exponential functions, we were taking logarithm of both sides, right? Here, we take, in this kind of question, we can take logarithm of both sides, we can take natural logarithm of both sides, or we can write, since e the positive number, we can not the take off, but we can write both sides of equation as power of e. So what do I mean? So this, I can write it like this. So e to the power of, why? So let me write here, e ln x plus 2 squared equals e to the power of 6. This is my new equation. Not the new equation, but now I write my equation in this form. Guys, remember, we have studied the properties, and one of them was, I write it here, a log of b base a, it was equal to b. I even remember which student wrote this on the board. I believe you remember it too. So, guys, do you see e here? And ln means the base is e. So here actually we have e, right? Log with the base e. It means the left side will be x plus 2 squared. Okay, the left side is x plus 2 squared. It's equal to e to the power of 6. Is it clear? Is it clear? Okay. And guys, now we have to find x. Find all solutions. It means we have to find x. What to do? Take square root of both sides. Okay. So what we have to do, these two cancel out each other. I have x plus 2 equals square root of e to the power of 6. What is square root of e to the power of 6? Okay, then I write it here. Square root of e to the power of 6 is e to the power of 6 over 2, which means e cubed. All the exponents maybe go out by division. So we divide the exponent by 2 in square root. In cubic root, we divide it by 3. In fourth degree root, divide this by 4, etc. So here we divide it by 2, it's e cubed. Okay. There is one thing here I didn't mention, because remember, these may be plus or minus. We are going to just after a minute. Okay, so we have x plus 2 is equal to square root of e to the power of 6. Actually, we have x plus 2 is equal to e cubed. And then we have, if we subtract 2 from both sides, we will have x is e cubed minus 2. Okay, so what about that one? We may have that solution also. Let's write it here. So x plus 2 is negative square root of e to the x. So x plus 2 is negative e cubed. Is it possible, guys? So remember the domain. Okay, domain is important all the time. All the time. Whatever we have, it must be greater than 0. Yes? Log of something that index must be greater than 0. So here we have ln x plus 2 squared. This is my original function, right? And here x plus 2 squared must be positive. Well, it's always positive because it's squared. So if x plus 2 is negative e cubed, well, square of it will be positive. Also, I have second solution from this equation. So x is negative e cubed minus 2. And this is the second solution. I hope it is clear. Well, what we did, let me summarize. When we have ln of a function, ln is equal to a number, we just write both sides as power of e, okay? So we are importing e to the function. And then, in this case, e and ln like cancel out each other, so we have just x plus 2, because of this property, by the way. X plus, so this x plus 2 square is e to the power of 6. And then it's basically finding x. I have to get rid of square, so I take square root of both sides. I have to get rid of plus 2, so I subtract 2 from both sides. I have this one as x. Of course, I have to make necessary simplifications. It's square root of e to the power of 6. Basically, it's e squared times e squared times e squared, and each e squared goes out as e. We had 3e squared, and 3e outside, it will be e cubed in other way explanation. And then also we have to consider when we take square root of both sides, square root, we have to be sure that we are having positive and negative of that. Of course, we cannot do that without considering the domain. Domain, we have to check domain here. Because we have square, it doesn't matter what x is, only x cannot be negative 2, because 0, it cannot be, you know. And that's it. We solve this and we get these two x values. We have question number 15. I hope we finish all on time. Yes, expand the logarithmic expression. All right, we know this, guys. So here we have division. I write it as subtraction. I write it here. Base is 10, it's not written. X cubed minus log of 100 y to the power of 4. Okay, and then here we have 3. I take it as coefficients. So 3 log x minus, guys, what do you see here? 100 and y to the power of 4. There is a multiplication. Okay, there is a multiplication here. So I write it as, attention, the parenthesis, logarithm of 100 plus log of y to the power of 4. You see? So this is, this, I wrote it here. Pay attention. Okay, guys? Well, there are some other simplifications here. This 100 can be written as 10 squared. So the first one is okay. I have 3 log x minus, in parentheses, that is log 10 squared, and plus it's 4 logarithm y. That 4 I write as coefficient. Okay, so it's equal to 3 log x minus, so I distribute this minus, guys, 2 log 10, that power I write as coefficient, and minus times plus is minus 4 log y. What you see? Yes, you are right. The value of log 10 is 1, since the base is 10. Base is 10 too. And then the final answer is 3 log x minus 2 minus 4 logarithm y. This is the final answer. Number 16. Oh, by the way, I see a question. So 2 solutions, the previous one? Yes, there are 2 Find all solutions, and we have two solutions here, first and second. Thank you for asking your questions, guys. Number 16, here it is. What is the solution of the equation? All right, remember, I said in exponential equations, we take logarithm of both sides. But if the base is e, we can take natural logarithm of both sides too. So I have ln of e to the power of x plus 7 is equal to ln 2. Wow. And that x plus 7 we write as coefficient of ln e, and it's equal to ln 2. Yes, guys, what is the value of ln e? It is 1, since the base is e. So we have what? X plus 7 equals ln 2. So what is the solution? What is the x value? It is ln 2 minus 7. Well, it may stay like this, or you can use the calculator. You find the ln 2 value. It's up to answer choices. Okay, guys. So if you have numbers in answer choices, you have to find the value of ln 2 and complete the subtraction. If you have this one, that will be the answer, of course. Number 17. What is the solution of OK? Well, this is kind of easy because we have to have, right, guys, here, logarithm of 2x minus 1, and base is 10. I write this as exponential. Okay. Does it make problem? Is it negative number? What do you think? Let's see. Here, let's see, guys, what I wrote here. Remember, let's remember here. Did I write anything about C? No, but the base and A must be positive, and B must be positive, B different than 1, and this also is A is bigger than 0, so A is not equal to 0. A is different than 0, A is bigger than 0, B is different than 0, and D is different than 1. C may be negative, okay? So there is no problem here. We can continue. So I write this in exponential form. Base is 10, the power is minus 1 equals to x minus 1, okay? So 10 to the power of minus 1 is 1 over 10. I have 2x minus 1. From here, 1 over 10 minus 1 is 2x. Yes, guys. And what is 1 over 10 minus 1? If I make equal denominator, or 1 over 10 minus 10 over 10, it's minus 9 over 10 is equal to 2x. And then to find x, I divide both sides by 2, and x will be equal to negative 9 over 20. All right, that is the answer of x. Well, that is one thing here we have to be careful. Yes, remember, this is okay, it can be minus, but here this must be positive, right, guys? This must be positive. Hey, wait a minute, I made a mistake, I think. 2x minus 1, why I write here plus 1? Oh, it's incorrect. Guys, okay. Here, everything will change. I have to update it. Why can it be negative? So there is no restriction for that one. Logarithm can be negative, okay? Logarithm can be negative because remember, when we write this in exponential form, negative power of any number, again, it's positive. So there is no problem here. Here, my problem here, I didn't write it correctly. It's 2x minus 1. So 1 over 10 is 2x minus 1. That minus 1 will be plus 1 here. And 1 over 10 plus 1, it will be 11 over 10. Yes, guys. And that will be 11 over 20. Yes, x is 11 over 20. We have to check it out. 2x minus 1 must be greater than 0. The domain 2x minus 1 must be greater than 0. If x is 11 over 20, 2 times x, so let me try it here, 2 times 11 over 20 minus 1. It will be 11 over 10 minus 1. Is it greater than 0? Yes, so no problem. This is the answer. Is it clear? Number 18. What is the solution of the equation? Okay, we have E again. Well, that is minus 1. So first I write it 4 times e to the power of x minus 1 equals minus 1. If I add 1 to both sides, I will have 12 on the other side. Yes. And there is 4 here. If I divide both sides by 4, I will have 3 on the both sides. Okay. Will I continue? Remember which question we did? We took ln anywhere? Not yet? Okay, guys. Oh, we did it here, right, guys? So we remember what we did. We take natural logarithm of both sides, and we are going to do it here. We have now ln of e to the power of x minus 1 equals ln of 3. I take natural logarithm of both sides. And then that x minus 1 we write as coefficient of the ln function. So we have ln 3. And yes, you are right. We know that this is equal to 1. If it's equal to 1, sorry guys. If it's equal to 1, I have x minus 1 equals ln 3, and x equals 1 plus ln 3. Okay, this is the answer. So again, up to answer options, it may be the answer, or you have to find the ln 3 value in your calculator and add that value with 1. That will be the final answer. Okay, is it clear? Okay, number 19. Write the expression as a single natural logarithm. Yeah, we had ln c. We had this kind of questions. It is easy, so we have to go back. 3 ln x can be written as ln x cubed minus, we have 2 ln c, it can be written as ln c squared. And since this is subtraction, I can write it as ln x cubed over c squared. This is the single natural logarithm. And the last question is, expand the logarithmic expression. Expanding, okay, base is b, all right. Well, can I simplify 57 and 74 here? 7, 11, 57. It doesn't look like. Okay, we will see later. Let's continue. First, I write it like this, guys. So root 57 over root 74. 57. Let's find the factors here, guys. Okay. 57 can be written as, it is 19, and it's 19. It's 3 times 19. What about 74? It's 37. and 37 is a prime number. 37 7 5 8 9 10 11 12 13 14 15 16 17 18 19. Nope. Yes, guys, it's 37. Okay, there is no simplification here. Okay, so continue. Guys, do you see here the division? How can we write the division? Yes, we write the division as subtraction. So log base b of root 57 minus log base b root 74. Okay, what can I write? That square roots I can write as a power, 1/2 power of, right? So I have 57 with the power 1/2 minus 74 power 1/2 base b. And finally, the final answer, 1/2 log 57 base b minus 1/2 log 74 base b. This is the final answer. I hope it's clear. I hope it's helpful. You can ask your questions, write in comments, okay, or during the class. Bye-bye.